Hello everyone, welcome to Pepcoding. In this video, we will look at the question container with most water. Okay, so let's see. In this question, we have n numbers, right? And we have to find those two numbers. So for every number, there is a line, right? And every line represents the height of that number. So we have to find two lines such like that if we try to make a container out of it, let's say I choose this line and this line, right? If I make a container out of it and if I fill it with water, I will get the maximum water, right? So if I choose these two lines and if I try to fill it with water, right, I can fill it till here, right? I can fill it up to this point because after it is going to overflow, right? Similarly, if I choose, let's say, this line and this line, then I can fill it till this point, right? If I choose this line and this line, then I can fill it till here, right? Something like this. So I need to choose those two numbers, or I need to find the maximum amount of water which I can store in such container, or the maximum area of that container, right? So let's say if I use this line and this line, right, 6 and 5, and if I choose these two lines, then I can fill this container till here, right? This is going to be my maximum height, or this is going to be the maximum height of the container. It is not the maximum height of these two, but it is going to be the maximum height of the container. Because if I try to fill it after this point, if I try to fill this container after this point, it is going to overflow. So it means that the height of the container is dependent on the minimum height of the two numbers. Okay, so if I have 6 and 5, the height of the container is going to be 5 because it is smaller. Okay, let's use two other numbers. Let's say I have this line and this line. Okay, for 6 and 8, my height is going to be till here, right? Because if I try to fill it over this, it is going to overflow. Okay, so this is going to be the height of the container itself. So the minimum height of the two numbers will be the height of my container. So 6 and 8, from 6 and 8, my height of the container will be 6. Okay, so I see that my height is equals to the minimum of my two numbers. So let's call this height of I and height of j. We will have two pointers, right? Let's call this I and j. So the minimum of I and j will be the height of the two numbers, or the height of my container will be the minimum of the height of the two numbers. Okay, so that will be my height. And now what is going to be the base, or what is going to be the width of my container, right? So if I choose this line, my width of the container will be between this point and this point, right? Between j and I, that is my range, and that is my width only. So my width is going to be it's going to be j minus I. Okay, because because I have to choose the range, right? And if I and j are pointers which are representing the two lines, then I need to find the range between them. So my range between them is going to be j minus I. Okay, so I know that my height is dependent on my minimum height. I know my width. I can find the maximum amount of water, which will be height, right? Height into width. Okay, that is going to be my height, or that is going to be the water which I can store. Okay, so now I need to find the maximum water which I can store using these heights and this width. Okay, so if I have this j here, if I have this I here, okay, what is the first approach which comes to mind? So the first approach which comes to mind is the brute force approach, right? In the brute force approach, I will have my I pointer here, and my j pointer will travel through all of this vector, right? It will travel through all these values we will have 0 comma 1, 0 comma 2, 0 comma 3, 0 comma 4, 0 comma 5, and and it will travel for all these vectors. Then I will increment to 1, and then j will start again, right, from 2, 3, 4, 5, and so on. So we will have 0 comma 1, 0 comma 2, 0 comma 3, 0 comma 4, and so on. We will have 1 comma 2, 1 comma 3, 1 comma 4, and so on, right? Then 2 comma 3, 2 comma 4, and so on. So we will have different permutations. We will have all the combinations, and we will see that which one of this pair makes up the maximum container, right? We will choose these two numbers. We will check for every single pair which one is going to give me the maximum area of my container. Okay, so that will be my brute force approach. And if I use this approach, then I am traversing n elements n number of times, right? So my brute force approach is going to take O of n square complexity, right? If it has n elements, then I am traversing n elements n number of times, right? So my brute force approach will take O of n square time complexity, which is not a very good approach. So let's try to optimize this a little bit. What is going to be my optimal approach? Okay, so now in this optimal approach, we will have this I and j pointer start from the beginning and from the end of the vector. Okay, so I is at this point and j is at this point. So currently for this example, I have my I and j at 1 comma 7, right? Now I will try to find the height and the width. So my height will be the minimum of, right? So I need to find the minimum of the values. So 1 comma 7, and it will give me 1, right? And what is going to be my width? My width is going to be the difference between 8 and 0, right? So 8 minus 0 gives me 8. So the water will be height into width, which is 8 into 1, which is 8, right? This is not my right answer, but this is the answer which is at this point. So it means that I can make a container like this. Okay, I can make a container like this at this moment. If I choose these two numbers 1 and 7, then I can make a container like this. Okay, this is not the right container. It only contains 8 units of water, but this is the container at this moment, right? So I need to either increase my I or decrease my j to get the right answer, right? I need to choose two numbers, right? I need to choose two heights. So I need to either decrease my I or increase my I and decrease my j. So now let's see what will happen if I increase my I. Okay, let's say I have I and I increase it. I'm at 1 comma 7, right? This is all happening for 1 comma 7, and here my I is at minimum height, right? Because 1 is minimum and 7 is maximum. From I'm only comparing 1 and 7 right now. So my 1 is minimum and 7 is maximum. So my j is at maximum, right? This is at max height between the only two values, between 1 and 7 only, right? So I can either increase and j can either decrease. Okay, so I can either increase, j can either decrease. Now we will check for I, right? There are two things I can do if my I increases. If my I increases, there are two things that can happen. Either my height is going to increase or my height is going to decrease, right? There are two things that can happen. Either way my height is going to increase or decrease, my width is going to decrease. My width will decrease regardless whether height increases or decreases, because I'm reducing the range, right? either if I increase my I or decrease my j, my width decreases because I'm reducing the range, right? If I have this vector and I is here, j is here, if I increase my I, right, the range is reduced, right? So it means that if I increase my I, then there are two things that can happen, that either height will increase or decrease, but in both cases my width will decrease. Okay, now what do we mean by that? If my width decreases and my height also decreases, then that means my water is also going to decrease, right? The total water which I can store will also decrease. But if my height increases and my width decreases, then there is a slight chance that my water can increase. This does not mean that it is going to increase, but it means that it can increase. Okay, water can increase, right? Let's check this for maximum height now, right? This was the case if my I was at here, if my I was at 1 and j was at here, right? So now let's check for j. Two things can happen, right? Either my height will increase or my height will decrease, right? If my height increases, then my width will also decrease, right? This will happen regardless. Width will decrease. But if my height increases and my width decreases, my water will also decrease. Here, my water will also decrease. Now, why is that? Why when my j is maximum and I'm decreasing my j, my height is increasing and my width is decreasing, but my water is also decreasing. Okay, let's take this case. Let's say I'm at 1,7, right? I'm at this point. Now, this is my this is my answer at this moment, right? For this moment, this is going to be my answer. So if I try to make a container, it will be like this only, right? It will be something like this. So now, if my j reduces, right? 1 and 7, I have 1 and 7, right? And 7 is maximum, and I'm trying to reduce the maximum at this moment. If I reduce my maximum, then my height is reducing at this moment, right? But it is not less than my minimum, and my height is always dependent on the minimum. So the new container will be something like this, right? This will be my new container. Here you can clearly see that it has reduced, even though the height hasn't really changed. The height of the maximum number has changed, but the height of the minimum number hasn't changed. But it is still affecting my answer because it is the minimum height, right? The range has reduced. Making my answer smaller. Okay, let's say this wasn't the case. Let's say my j was here, right? And here the value was 8. Instead of 3 here, the value was 8, right? And we had a graph like this, right? This was still 8. Now, I have these values, and my current graph or my current container will be like this, right? This will be my current container. But if I reduce my j now, right? Now, if I reduce my j, my height will also increase, but my width is decreasing. And I said that my water is going to decrease regardless, right? I said that if my j decreases, and j is maximum, then if the height increases, it does not really matter because my water will still decrease. So let's say I'm at here, right? And I reduce my j and my height is increased. My height is now 8, but the minimum height is still 1, right? My minimum height is still 1. So this will be the range that I will get. Now, before we had 3 here, right? Is there a difference between 3 and 8 at this moment? No, right? I reduced my maximum height, but it doesn't really changes the height of my current container, right? It doesn't really change the height of my container because it is the height of the minimum value, right? So I said that if I reduce my maximum height, my water will decrease regardless because my width is decreasing. My width is decreasing. The main reason is my width is decreasing, right? This is the gap which was covered, right? This is my gap. This is the gap of the width. So I'm saying that if I reduce my width, if I reduce my j, or if I increase my I when it is the maximum, right? When it is the maximum at that point, then it won't affect my container height. It will affect my container range, hence reducing my water. So I only need to increase my I or decrease my j when my height is minimum, because that is the only chance when my water can increase, right? That is the only chance when my water can increase. So, so I will either increase my I or decrease my j only when my water can increase, right? And only when my I and j are minimum. Okay. So I hope you understand this approach. Now let's try to code this. And if you don't, if you have even a slight idea of how it is working, it will be more clear as we will dry run the code. Okay. So let's try to write the code for this. Okay. So first we need a I pointer, right? I and j. Now j is at the end, right? So heights dot size minus 1, right? We also need a water, and we will return this water only. Here my algorithm will work. This will work while I is less than j. And why I is less than j? Because when I and j are equal, let's say I becomes equals to j, right? I and j are equal at this point, then I only have this single line, right? And this single line cannot make me a container. So I need my I and j to be at different values. Okay. So this will work when I is less than j. Okay. So while I is less than j, I will calculate my height, which is going to be the minimum of the two heights, right? So heights of I, comma heights of j. Now it gives me the minimum height, right? So I just need a width. Now what is my minimum, or what is going to be my width? Width is going to be j minus I, right? And what is going to be my water? Water will be the maximum value between the old water and the new water. So water will be height times width. Okay. So this water will update only when my height times width, or the new water is greater than my old water. Okay. Now I found the I found the water, I found the height, found the width. Okay, I just need to increase or decrease my j. I need to increase my I or decrease my j, and it is done on the basis of the height value. So if heights of I is less than heights of j, then it means that I need to increase my I, because the height of I is smaller. Else I will decrement my j. Okay, so this looks fine. Let's run this code. It is accepted. Let's submit this code. It is also accepted. Now let's try to dry run this. Okay, so we have this, right? Let's take this code. Okay, so we have this here. Now we have our I and our j pointer, right? And j is starting from the end. So let's erase the rest of this. Okay. Now we are here. Okay. So while I is less than j, I is definitely less than j, then my height will be the minimum of the two heights. So the height will be 1, right? Height will be 1. My width will be j minus 1. Width will be 8, right? Because 8 minus 0 will give me 8. Now my water, my old water was 0, right? I initialized my water with 0. So my new water will be the maximum of my old water, which was 0, and my current water, which is 1 times 8. So my water is also going to be 8. Okay. So we updated my water to 8. Now my height of I is less than heights of j, right? I 1 is less than 7. So I will increment my I. Okay. Now I is also less than j. So I will go in this loop again. Height is equals to the minimum of the two values. So my height is going to be 7, right? What is going to be my width? 8 minus 1, which is 7. So 7 times 7 gives me 49. Now my new water will be the maximum of 8 and 49. Now it will increase. Okay. So my new water will be 49. Okay. So I have I and j here. Now my j is less than I, right? You can see that my j is less than I. So I will decrement my j. Now I have 8 and 3. My height will be 3. My width will be 7 minus 1, which is 6. Now my current water will be 3 times, or let's call this water. This is confusing with width. This is my water. Okay. So 6 times 3 gives me 18. 18 is not greater than 49. So it won't affect it. Now 3 is less than 8. So I will reduce my j. Right. Now we have 8 and 8. So my height will be 8 only. My width will be 6 minus 1, which is 5. 8 times 5 gives me 40. 40 is not greater than 49. I will reduce my j because I and j are equal, right? Here at this moment, heights of I and heights of j are equal. And for that, I am doing j minus minus. Okay. So now I have 8 and 4, right? Now the minimum of the two are 4, right? And my width is going to be 5 minus 1, which is 4, right? So my water is going to be 16. 16 is not greater than 49. So I will not update it. Now I will decrease my j again. Okay. I have 5 and 8. So my height will be 5. My width is going to be 4 minus 1, which is 3. So width is 3. 5 times 3 is 15. 15 is not greater than 49. I won't do anything. I will reduce my j, right? So I have 8 and 2. Now my height is going to be 2 and my width is going to be 2. 3 minus 1, which is 2. 2 and 2 gives me 4. 4 is not greater than 49. So I will not update it and I will reduce my j again because it is smaller. Then we have 8 and 6. 6 is smaller. So my height is 6. My width is 2 minus 1, which is 1. Right? So my new water will be 6. 6 is not greater than 49. I won't update it. Now my j reduces. I and j are equal. The loop terminates and I get 49 as my water. Okay. So this was the right answer. I hope you understand this question. If you don't, I would suggest you watching the part which you don't understand, especially the part why we are increasing our I and reducing our j when my height is less than heights of j. Okay, or when my height is smaller, when my height is smaller, then I'm reducing, then I'm incrementing, or then I'm making the change in my operator, or then I'm making a change in my I and j. When my height is smaller, I'm only making the change when my height is minimum. Okay, that is the main point that is need to be noted. So don't forget to like, share and subscribe this video. Thank you for watching.